Okay, welcome back. This episode we're going to check after each move to see if the game is over either by the user winning or by the board being full with no moves available to make. So we're going to start by adding a new field to the class game, and it will be a Boolean. It will be a private Boolean called game over. And when the constructor is called, this will be initialized to false. In addition to adding the game over field, we're going to add a accessor, public Boolean get game over, which will return whether or not the game is over. Also, we'll probably put this function below all the push functions at the end. This will be a public Boolean method called check game over. And this will be called after the player makes a move, and it will determine if a 2048 or a 1024 in this case is present. I've actually changed my mind about this. We are not going to have this. We're going to create a new enum. So I'm going to add a new file, and it's going to be called gamestate.java. And if we open this up, it's in the same package as everything else. And it's going to be a public enum called gamestate. In an enum, or enumeration, we're going to list all the possible values that a game state could have, which are not ongoing, what should I call it? Continue, win, or lose. Those are the three possible states. Now that we've created the game state enum, we can actually have the game state as a type of variable. It'll be a private game state called state. In the constructor, we will initialize it to gamestate.continue. Instead of public Boolean get game over, we will return a game state, and the method will be called get state. And it will return the state. Now, at the end, we will make a public void called check state. And this will be called after every single move to determine what the state should be, whether the user can continue playing or whether the user has to stop because he either won or because he lost. From that function we'll need to call a few others. So we'll start creating those first. This will be a public Boolean check for 1024. We'll also make public Boolean check board full. The other method will be check has moves. So let me do something I rarely do and try to do a modicum of documentation here. Returns true if a 1024 is on the board. This one will return, get rid of the S. True if the board is full of tiles. And this one will return true if there are any adjacent numbers. So let's just do this one first. We have a game board that's a two-dimensional array that can be accessed. So we're going to do the 4y and 4x thing. Actually, for x and 4y. We're int x equals 0. Operating as long as x is less than 4, since that's a 4 by 4. Iterating x each time. This is going to be a nested for loop where we go to each possible position in the two-dimensional array and check if the value is 1024. So for the y values now, same sort of pattern for the y. If game board x y is equal to 1024, we will return true. If we get to the end without having returned true, we can return false. Now for check if the board is full, we can copy the same sort of logic, except for once we have our x and y, we're going to check if it's 0, and if there's a 0, we'll return false. Otherwise, we can return true. Okay, for this function, we are going to iterate through it. We're going to use x to iterate through the rows, which is a little bit backwards. The x and y are backwards from normal because of the way that the array is set up. Now, within this thing, we want to look at each column position. So the column is y. So it's a similar nested for loop, well, the exact same nested for loop so far that we've done before. We'll need to do a few things in it. There's nothing really to do with the top left corner. If we're in the top row, we don't need to check the row above it because we can't. So if x is 0, we're going to do something differently than we will do for all the other times. In addition, we don't need to do something for the first one in the first row. So actually this will operate if y is not equal to 0. We're in the first row here because the if x is equal to 0. So now we want to see if game board at x and y is equal to the game board at x, y minus 1. What this does is check and see if the position in the first row that we're looking at is equal to its predecessor, the column before it in the same row. If it is, we can return true because those are two numbers that could be combined. Now we're assuming by the time this function is called that the entire board is full of numbers. We're only going to check this if check board full returns true. So we'll do this process for each column in the first row except for the first column. Now, in any other case, if x is not equal to 0, we'll do something a little bit more complicated. In addition to checking for the previous column being equal, we also need to check if the number directly above it is equal. So, if y, we can actually copy this whole part in here because we still want to check the previous numbers if we're not looking at the first column. The previous numbers in the same row, that is. But now we also want to check whether y is 0, 1, 2, or 3. We do want to check the number above it. The game board at x and y, we already know that x is not going to be 0 when we get to this, so it's 1, 2, or 3. So we can safely access game board x minus 1, which is the previous row, at the same column. If these two numbers are equal, we also want to return true. I'm hoping that this logic should cover every possible situation in which there could be two adjacent numbers. We'll find this out in testing, but if we get to the end of the function and haven't found any adjacent numbers, we can return false, which will mean that the user has no moves, assuming again that this method is only called when the board is full. Now we're going to go to this check state method, and we will use the three methods that we just defined to determine the state. So check state method again will run directly following a push up, push down, push left, or push right, which is the response from the user input. So the first thing we're going to do is check if 1024 exists. So if check for 1024, if that method returns true, then state will set that to GameState.win. And then else if the game is, or the board is full rather. So check board full. If the board is full, we want to branch out into two possibilities. So if the board is full, then we want to check if there are moves using the function we most recently defined. Check has moves. If he has moves, then the state is going to be GameState.continue. Otherwise, if he doesn't have moves, then the game is over. What did I call that? Lose. Okay, that's what I thought. GameState.lose. Now, it's possible that neither there's a 1024 nor is the board full, in which case we also need to make sure that the state is GameState.continue, although really anytime this function is called, if we design it right, the game state should already be in continue. So this line should be unnecessary, but it's there as a precaution to make sure that no matter what, when we call the check state method, the game state is explicitly set to whatever it needs to be set to. Now to make sure that we are using that properly, we're going to do a few things in the GUI class. Let me find the key listener part. Okay, for the key release things, we only want to actually do any of these push up, push down, push left, and push right things if the game is in a continue state. If the game is in a win or a lose state, we don't want our program responding to the arrow keys. So I'm going to add a new statement. If game.getState is equal to GameState.continue, then I'm going to indent all of these statements and put an ending brace there. So these things will only be done when the game is in a continue state. Later we'll add responses for the enter key when the game is in win or lose, where we'll display a message saying press enter to start again or something along those lines. But for now we're just going to limit the key responses this way. Now before we add a new number, actually it's after we add a new number, that we want to check the function we just did, which is, what is it called? Check state. So at this point we want to do game.checkState. Which will make sure that the state of the game is updated. And we'll do that every time after we add the new number, because adding the new number could fill it and be the thing that ends the game. So we want to check the state after the new number is added in each of these functions, methods, whatever. Now, to make sure this is all working properly, outside of this game state check, at the end here, I'm going to print the game.getState. So hopefully it will tell me when the game state changes. So let me see if this right here will compile. That'll be the first challenge. Star.java. That compiled. Now jar cvmf, hopefully I remember this all. Manifest.txt 2048 java.jar. No. Java 2048.jar. Common images. Hopefully I'm doing that correctly. Looks like I did. Now Java jar. Okay. Okay, it doesn't seem to actually be printing anything. I probably need to add a toString method or something. Let me do this more explicitly then. Game state gs equals game dot get state. If gs equals game dot, no, if it equals game state dot continue, then we want to print continuing game, and then else if gs equals GameState.win, we'll print game over, user wins. And then the only other possibility is that the game is over and the user loses. I need to make sure I'm putting the compiled classes into the bin folder and run it. Okay, that was a problem. I just wasn't putting the newly compiled classes in the right folder. So I'm gonna keep pressing up until the board fills up, and hopefully I see it happen when the game runs out of moves. Ooh. Let's see what happened. So something's not working. It thinks there's moves. What happened here is it, before it got to even check if adding a new number would end the game, it tried to add the new number and there were no spaces for the new number. So currently I pressed up when there was no possible upward move that I could make, so the game board after I pushed up was exactly the same as the game board before I pushed up, which was one that was completely full of numbers. And then it tried to place a number on the board. So we need to do something about that. So that is in the game class where we add a new number. Let's find that. I remember when I typed this one up, I said it would be assumed that there would be empty spaces because before that happens we would check. So let me think. I've already created a function for checking if the board is full, so if the board is full, we'll just return. So if check board full, then we will return, and shortly after this point we will check and see if the game is over because of that board being full. So if the board is full after the person presses a button, we just won't add a new number. And then we'll let the next check state function, when that's called, next time that the check state function is called, we'll actually find out if that is because the game is over or simply because the user pressed a arrow where there were no possible moves when the board was full, but there might be possible moves in other directions. So hopefully with this change I can do the same thing and I'll get a more informative result. Okay, I compiled it. I'm going to put it back in a jar. Oops. I need to go to the bin folder and then try and put it in a jar, and then I can go ahead and run it. Alright, let me just keep pressing up for a while. As you can see down here, each time it says continuing game. Okay, now it's continuing the game as I press up because, good, it's allowing me to press up and it's not crashing, but it's not ending the game because I still have moves. So let me try and get rid of all my moves and keep pressing up. This might be a problem because I don't see that I have any moves available to me. Up, down, left, right. Okay, for some reason it appears to be returning true even though I have no adjacent numbers, so I did something wrong there. So we'll take a closer look at that. Okay, I'm currently double checking the check state function. If the board is full and the person has moves, game state should continue. So let me look at has moves. Okay, I'm recording this really briefly. I actually lost a video where I made the correction to this check state function. So I'm going back and explaining it. What I had done is, after the if statement finishes right here, I had state equals GameState.continue. So no matter what had happened in this if statement, at the very end of this method, I set state back to GameState.continue. I had forgotten to put else. So I went back and included else when I found the mistake, and I might not have been recording when I did that because I don't have the original video from when I first did this. Now we'll go back to the original footage. Okay, so beneath our declaration of the game board private class within the GUI class, we're going to create two more subclasses. The first one will be WinBoard. It will extend JPanel. And it will override the paint component. And we'll have another class called the LoseBoard, which will also override paint component. What we're going to do in each of these is write the word win or lose and the string press enter to try again, or something along those lines. These panels will be displayed when the game is over, and upon the user pressing enter, we'll go back and start the cycle over again. Okay, the first thing we're going to do is set the color and fill the background with the same 20-20-20 gray that we filled the game board with. So I'm actually just going to copy these two lines from the game board and place them in the WinBoard. Okay. At the beginning of the GUI class where we declare all of our variables, I'm going to add a few. This one will be a font, large feedback font. Will be a new font of sans serif. Let me double check the arguments for creating a font. Second one is the style and the point size. Point size will start with 40, and then we'll create a font, small feedback font, as a new font. Let's go with 20. We'll see how these go for now. So once we've filled the color of the WinBoard, or filled the rectangle of the entire WinBoard with this color, we will set the font to large feedback font, and then draw a string called you win at 20 and 10. That will be the position of 20 over and 10 down within the win board, and we'll just see how that looks and adjust it as necessary. Then we'll set the font to small feedback font and draw the string you lose at, say, 20 over and 30 down for now. We'll have to see how that looks. And we will, oops, this part doesn't want to say you lose. We want to say press enter to play again. Okay, so we're also going to copy all of this and put it into the lose board. And instead of saying press enter to play again, we'll say press enter to try again. And now we've got to edit our listeners so that if the state was continue, after it responds to the key event, we will have to check the game board. We'll create a variable called GS, which is of the type game state, which is the enum we declared, and it will be game.getState, so it will return either win, continue, or lose, and we're only checking on key events when at the beginning of the key event the game state was continue. So then if GS is equal to GameState.win, we're going to want to display the win board. Although it's more likely probably that the game state's going to be lose. So let's check that first. Otherwise, if GS is equal to GameState.win, we'll want to display the win board. So if the game state is lose, we want to call frame.getContentPane.add, and we're going to add a new lose board at the center, border layout dot center. Otherwise, if it's a win, we'll do the same exact thing, except we'll add a new win board. I'm not sure. I believe that adding this directly to the frame will result in the entire game board being taken over with this new board. But we'll see what happens when we run out of space when we try this. Okay, let's run this until we run out of space. Okay, something isn't working. The board is full. There are no adjacent numbers. It's stopped responding. Something's wrong. Okay, since that didn't work, I'm going to try removing the game board first and see if that fixes the problem. I'm not entirely sure how to remove a J panel from an area of the J frame and replace it with another one. So that's what I'm working on now. Alright, let's try and run this out of space real quick. Okay, so I ran it again. I made some changes. I'll show you what they were in a second. And now I come up with this black board whenever I lose. Added frame.getContentPane.invalidate and .validate to the piece of code where I replace game board with a new lose board. And the result was this black panel, and that is probably because of how I did the paint function. I need to change the color before I draw the string, since it's drawing a almost black string on a almost black background. So before we write you in, I will change the color to 0, 80, 0 for some kind of green, good-looking, positive feedback. And before I draw the press enter to play again, I will make the color white. Before I draw you lose, I will set the color to a new color that will be a hostile looking red color. And I'll use white again to tell the user to press enter to try again. Okay, let's fill this up. Okay, I'm drawing this too high for some reason. It's writing you lose above the beginning, and that color is off. But at least we know this part is working. Let me see what's going on with why we're drawing the string weird. It looks like maybe we are drawing the string. When I give it the coordinates to tell it where to draw the string, it's referring to the bottom corner of the string instead of the top corner. So let me adjust this briefly. Okay, I looked it up and I was correct. When we draw a string, these numbers, X and Y, refer to the bottom left corner of the text box that we're drawing. So I need to move the Y values down more. The X values looked appropriate, so I'm going to move it down to, say, probably where the press enter instruction was, over at 30. And I also want to change the red color to maybe 200, a brighter red. And we don't want to draw the press enter string on top of it, so we probably want to go down to 60 for that one. Let me correct that in the win method as well. And let's try again and see how this one looks. Okay, it's been compiled and jarified. Now we're running it again, and I'm going to fill it up again. Okay, that is a little bit better. It's still too high, so I'm going to move it all down by another 10 or 20. But I like how it's coming together. So I'm going to move this down to 40. And the press enter string down to 70. Same with the lose board. And if this looks good, we can move on to the last part, which will be listening for enter. And on enter, we'll restart the game. So let's save this. I'm going to go ahead and compile this now. Okay, here we go again. Okay, here we go. This is sort of how I want it to look. The only difference, if I had won the game, it would say you lose in a green color, and it will say press enter to try again as well. So we need to edit our listener. The listener actually belongs to the whole frame, so we don't need to make any new functions here. We can just use public void key released. And if the game state is gamestate.continue, we check for the arrow keys. I'll line up the brace here. But if it is not gamestate.continue, then it's either gamestate win or lose, in which case the only key we need to check for is the enter key. We already are getting the key code before we enter this branch statement with the ifs. So let me just copy this line. And I need to double check the key event for enter real quick. So, okay, it's pretty straightforward. The constant I need to use is key event underscore key event dot vk underscore enter. So if that is the key, we want to do something. What I want to do is set the game to equal a new game. So resetting the game to a brand new start. And then I want to get the content pane, and here I'm running into a problem because I want to remove whatever's there. Okay, what we need to actually do is this line here. We're going to remove whatever's at borderlayout.center. To do it, I need to get the layout and then get the component that's at the layout. That's a little bit complex, but otherwise I would have to know which JPanel was in the center, and I want to do this one statement regardless of whether or not the win board or lose board is being displayed. Anyway, I never saved this win board or lose board to variables, I just added them. So hopefully this works. And then I want to do, actually, I need to add get content pane to that line above. I also need get content pane dot add back GB. I'm going to repaint GB so that it reflects the new game that was just created. And then we want to invalidate and validate the frames content pane, just like we did up here. Not sure why those are required. I'll have to look more into that. So I believe that this will make it so that when we press enter from the win board or lose board's instruction panel, a new game will launch and will repeat the cycle. If that works, then this episode is over with some successful results. Let me compile this real quick. Okay, it's compiled and jarified. Let's run it and try and fill it up real quick. Okay, here we are at the you lose screen. Let me press enter and see what happens. And as hoped for, it is back to a full cycle. So that's the end of this episode. In the next episode, we will implement the score and high score functionality so that it updates every time combinations are made with a new score. That will require some checking of what takes place in the push up, push down, push left, and push right methods, and recording whatever numbers are combined and adding that value to a score variable. So we will worry about that next episode.